Okay, next for example 5, the next case or next application, which is the block on the slanted surface. Okay, this is a slanted surface, the block on the slanted surface with an angle of 30 degree, with the coefficient of friction is 0.2, means there's a friction, means it's a rough surface, not the smooth surface. So given a block with a mass of 5 kilo on the slanted surface with the coefficient of friction is 0.2 at 30 degree, determine the acceleration of the block on the surface. Okay, first you have to draw free body diagram. I draw it back here. (30 degree) with the block of 5 kilogram with the mu of how much? 0.2. Okay, make sure you draw it back because we will not take your question paper, but we will take your answer paper. So please draw back the free body diagram. Once you draw free body diagram, you will get marks. Okay, next we have to okay, draw all the forces. Okay, what you will assume, this is the slanted surface, so the object might go downward, right? So we just assume downward. If your acceleration is negative, final answer, if your acceleration is negative, it means the direction is upward. But if your acceleration answer is positive, means it's downward, means follow the slanted surface direction. All right, most probably common sense. Okay, common sense, the object will go down, right? Okay, so simple. So we just assume acceleration is going downward. Okay, so the free body diagram of the object itself, you have normal force. Okay, now your axis is not like this. Here is y, here is x. It's not like this. It's supposed to be slanted. Here is y-axis, here will be your x-axis. Okay, please remember this because slanted and straight surface is different. Okay. Okay, so here is the normal force. Normal force always perpendicular to the surface. So the surface is slanted, so normal force is upward like this. If the surface is like this, for example, the block is like this, so the normal force is upward like this. Okay. Okay, so normal force is up there. Weight is always downward, right? Even though it's slanted or not, it's still downward. So weight is like this. But now here will be our axis, right? So if the weight is like this, of course you will have y-axis and x-axis, which is wy and wx. So if 30 degree is here, where is 30 degree at component of y? Is it here or here? Very good. You guys such a clever students. Okay, here is the slanted surface. 30 degree is here, right? So here is the object. The weight is downward like this. So here how much? 60 degree, right? So if the weight is like this, here will be 30 degree. It's Pythagorean torus. All right, so here will be 30 degree. Here 60 because this triangle, 30, 60 and 90. Right, so I just choose one angle only, not to be confused. So 30 degree is here. So wy is equal to w cos 30 degree. If there's an angle, you use cos. If there's no angle, you use sine. W sine 30. Okay, clear? If not clear, if you're still not understand, try to understand slowly. All right. So if the object move here, here will be your friction. So that's all for free body diagram. Here you have normal force. Weight is downward, so there's a component of weight. So here is wy, here is wx. So W cos 30, because the angle is here, is Pythagoras theorem. So Wx will be W sin 30 because there's no angle here. Acceleration, we just assume downward. So that's all for free body diagram. Now we want to make the calculation to find the, you have to find the, determine the acceleration of the block on the surface. So you have to find A. Okay, first of all, here is your diagram. So you have X axis and Y axis. Just now the block move in X axis, right? Okay, X axis. So X axis F is equal to MA because it's moving in X axis. How about Y axis? Y axis, the object doesn't move in Y axis. The object is not jumping. So Y axis F is equal to 0. Okay, good. Next, total force is equal to MA. So what force you have in X axis? So we refer back to the diagram. So here will be your X axis, right? X axis, you have friction force and W sin 30. So which one is follow acceleration? F or W sin 30? Very good. So W sin 30 arrow follow acceleration arrow, right? So will be positive. So W sin 30 minus F is equal to MP. W sin 30 minus friction force is equal to MA. If you expand, mg sin 30 minus mu n is equal to MA. Then substitute all the value. The mass given is 5 kilogram. So 9.81 sin 30 minus the coefficient of friction is 0.2 given in the question. Normal force, you don't know, is equal to 5A. Alright, this is the first equation. Okay, next for y-axis. Y-axis, F is equal to 0. So what force in x-axis, in y-axis, sorry. So circle the force in y-axis, this one, right? So here is y-axis. So n minus wy or wy minus n. If y-axis, the object doesn't move like this, right? So F is equal to 0, follow axis rule. It means upward is positive, downward is negative. So n minus w cos 30 is equal to 0. N minus w cos 30 is equal to 0. So n is equal to w cos 30 after you bring this one to right hand side. Okay, this is simple mathematics. So n is equal to, expand weight, you get mg cos 30. So n is equal to 5 times 9.81 cos 30. How much? N is equal to 42.48. If some of you get similar, maybe for 42.5, it's okay. 42 plus 40, it's okay. It plus minus, because some of you take the whole cos 30 value, some of you round off. Plus minus means the uncertainty arrange the around 42 numbers, 42 value. Okay, so normal force, you get 42.48 Newton. So normal force, substitute into this normal force. So 5 times 9.1 sin 30, you will get 24.53. From here, you get this one. Minus, you just follow minus, 0.2. Normal force, this one. 42.48 is equal to 5A. Copy, just copy everything. So you solve this one. You find A. A is equal to 3.21 meter per second squared. This will be your answer for acceleration. Okay, clear? Okay, this one just a direct question. You have to find acceleration. Okay, now we move to the next question example, which is example 6. Okay, this example 6 relates with all the strings. There's no surface at all. It means the object hanging on the ceiling. Alright, given a block of a weight of 150 Newton hanging on the ceiling. One string hang on at the angle of 60 degree and the other one is 30 degree. Determine the tension in each cable. Okay, first, how many tension you have here? Very good. You have tension number 1. You have tension number 2. You have, actually this one tension number 3, but later I teach you how you separate it. Okay, so you have 3 tension. Okay, this one, mass or weight? Very good, you understand clearly. Okay, so if the unit is Newton, it means it's a weight, even though that's in the question given. Okay, if Newton means no need to times with the gravity. Normally we calculate W is equal to mg, right? Weight is equal to mg, but now it's given weight already, so you no need to times with the gravity. Okay, next we have to draw free body diagram. Okay, so here will be your, you know that here is tension 1, tension 2 and tension 3. So I draw the other free body diagram. So here is x and y axis. So just now T1 is here, T2 is here, and T3 is here, right? If you draw it separately, T3 will be go downward, but for the object itself, the object 150 Newton is hanging, so tension will be go up here, weight will be here. Okay, if you combine with the 2 tension here, T3 is equal to weight. Okay, for T3 you can directly know for the tension 3 value. Okay, for T1 and T2 you have to calculate simultaneously. Okay, next, where is the angle for T1? T1 here is 60 degree, right? So it's alternate angle. So here is 60 degree. So in the diagram given here, here will be 60 degree, alternate angle. So here will be your 60 degree. Same with this 30 degree. If 30 degree is here, so alternate angle 30 degree is here. So okay, now we want to separate it into components, which is x and y axis. So here will be your T1 cos 60 for x-axis, T1x, okay? So T1y will be T1, sorry, sine 60. We use sine because there's no angle here. Actually, you even can use T1 cos 30, but I will not confuse you with this 30, so I stick with 60. All right, so here will be T2 cos 30, and for T2y is T2 sine 30. Okay, here will be T3 is equal to W. So settle for x-axis and y-axis. Okay, now it's time to do simultaneous equation. Okay, first of all, before we solve T1 and T2, we can directly get T3 answer. Okay, for T3, what is the equation for T3? Okay, for the whole situation or for the whole application here, what Newton's law you will choose? First law, second law, or third law? Okay, good job guys. It's first law because the object is hanging. Means the object is not moving. Assume there's no wind. Okay, so Here F is equal to 0. So what force in y-axis here? T3 and W. So T3 minus W, because is equal to 0, follow as this rule. So T3 minus W is equal to 0. So T3 is equal to W. So what's the value of W? Weight is equal to 150, right? So T3 is equal to 115 Newton. So that's the answer for T3. Directly you can get the answer. Okay, if your calculation wrong here, you should get the marks here. It's so easy. Okay, now we solve for T1 and T2. T3 solve. Okay, so for T1 and T2, you have x-axis and y-axis, right? So for x-axis and y-axis, both of them is F is equal to 0 because the object is not moving. So what force you have in x-axis? Here will be your x-axis. Remember, if F is equal to 0, on your right hand side will be positive, on your left hand side will be negative. So T2 cos 30 minus T1 cos 60. T2 cos 30 minus T1 cos 60 is equal to 0. So T2, you can calculate cos 30 is equal to 0.87 minus T1 cos 60 is equal to 0.5 is equal to 0. So T2 0.87 is equal to T1 0.5. T1 bring to right hand side. Okay, so T2 is equal to 0.5 divided by 0.87 T1. So T2 is equal to 0.57 T1. Solve for T2. Now for y-axis, F is equal to 0. What force you have in y-axis? So here will be your y-axis. So T1 sine 60 plus T2 sine 30 minus T3 or minus W. It depends on you. Okay, so T1 sine 60 plus T2 sine 30 minus T3 is equal to 0. If you minus W also can. Okay, so solve. T1 sine 60 is equal to 0.87 plus T2 sine 30, you calculate in your calculator, you will get 0.5. T3 you bring to right hand side is equal to 150. Just now you already calculate. Okay, so T1 0.87 plus T2, here is T2 is equal to 0.57 T1, right? So put it here, 0.57 T1 times 0.5, you just follow this one, follow equal 150. So solve. T1 0.87 plus 0.285 T1, because 0.57 times 0.5 times T1 is equal to 150. So you combine these two, you will get, after you calculate, you will get T1 is equal to 130 Newton. So you already get answer for T1. Now how would you get answer for T2? Substitute this answer into here. That's why we call as simultaneous equation you learn in high school. So 0.57 T1 is equal to 130. Answer 74.1 Newton. Some of you here, you will get 129 point something. It's still okay, doesn't matter. Okay, as long you will get similar plus minus 1 or 2 is okay. Sometimes here you get 75 or 74.3 or 9. It's okay. Okay, it's plus minus. So here your answer for what? Tension 1. Here your answer for tension number 2, and tension number 3 answer will be easy peasy, right? So that's all for this chapter. Good luck and try your best to do exercise more and more. Okay, if you still don't understand, please meet me. Thank you very much.